What if XRP was never meant to compete with smart contract platforms, but to plug into them? That reframe sounds small, but it changes everything about how you evaluate what is currently being built around the XRP ecosystem. For years, the criticism leveled at XRP from within the broader crypto community was consistent and straightforward. It is a payment coin. It does not do smart contracts. It cannot participate in DeFi. It is missing the programmability layer that makes Ethereum and its competitors interesting to developers. And for a long time, that criticism was largely accurate as a technical description of what the XRP ledger was designed to do and what it was not. But the framing always contained a hidden assumption that programmability had to live on the same chain as the asset itself. That an asset needed to be natively smart contract capable to be useful in decentralized finance. That assumption is now being systematically dismantled by infrastructure that is operational and growing, and understanding how it works changes the picture of where XRP fits in the evolving landscape of programmable finance. XRP was built with a specific engineering philosophy that is worth understanding before discussing what is being layered on top of it, because the design choices that made it limited in some directions also made it exceptional in others. The XRP ledger was designed for one primary purpose done extremely well: moving value across borders quickly, cheaply, and reliably. It settles transactions in 3 to 5 seconds. It processes those transactions for a fraction of a cent in fees. It has been operating continuously since 2012 without a single day of downtime, across thousands of validator nodes distributed globally. It was not designed to run complex computation on-chain. It was not designed to host general-purpose smart contracts in the way Ethereum was. Those were deliberate architectural decisions, not oversights. The engineers who built the XRP ledger understood that adding general-purpose computation to a payment and settlement layer introduces complexity, attack surface, and potential points of failure that are incompatible with the reliability requirements of infrastructure that financial institutions need to trust with high-value transactions. The trade-off was explicit: simplicity and reliability in settlement, in exchange for flexibility and programmability. For its intended use case, moving value between currencies and jurisdictions at institutional scale, that trade-off is rational. But it did create a genuine gap between what XRP could do natively and what the growing DeFi ecosystem required. The gap between XRP's native capabilities and the programmability requirements of decentralized finance was a real constraint on the asset's ecosystem development for years. Ethereum and its competitors attracted developers because they could deploy smart contracts that created lending protocols, automated market makers, yield-generating products, and complex financial instruments directly on-chain. Users could interact with these protocols permissionlessly, without intermediaries, using assets they held in self-custody wallets. XRP holders could not do any of that natively. If you held XRP, you could send it, receive it, and use it as a bridge in Ripple's payment corridors, but you could not lend it against collateral in a decentralized protocol. You could not deposit it into an automated yield strategy. You could not use it in a cross-chain swap with assets on other networks without going through centralized exchanges that required you to surrender custody. That limitation was not a fatal flaw in the context of what XRP was designed to do, but it was a real constraint on the breadth of use cases available to XRP holders, and it left an entire category of financial activity, the rapidly growing category of on-chain financial primitives, largely inaccessible to the XRP ecosystem. The infrastructure being built now by Flare and the Yellow Network is specifically designed to close that gap without requiring any changes to the XRP ledger itself. Flare Network is a separate Layer 1 blockchain with its own native token, its own validator set, and its own execution environment. It is not a layer built on top of the XRP ledger. It is an independent network that has been specifically architected to bridge external assets, starting with XRP, into a smart contract environment that is compatible with the Ethereum virtual machine. The EVM compatibility matters because the Ethereum development ecosystem is the largest in crypto. Every smart contract developer who has built on Ethereum or on any of the dozens of EVM-compatible chains that exist can deploy their code on Flare without learning a new programming language or rebuilding their tooling. The bridge that Flare has built converts XRP into FXRP, a wrapped representation of XRP that exists on the Flare blockchain and can interact with any smart contract deployed there. The wrapping process is designed to be secure and verifiable, with the underlying XRP held in custody while the FXRP representation circulates in DeFi protocols. Since launching its XRP bridge in September 2025, Flare has attracted over 132 million XRP from retail users who chose to bridge their holdings onto the Flare network. That number represents organic adoption driven by actual user decisions, not artificial incentives or inflated metrics. 132 million XRP is a real capital allocation by real users making a deliberate choice to expand what they can do with their holdings. The yield product that Flare launched in partnership with Zaman attracted an additional $2.5 million in XRP deposits into its Upshift vault within days of launch, and 97% of depositors continued to hold and earn rather than withdrawing, indicating what the industry calls a sticky user base, meaning users who found genuine value in the product rather than users who came for a short-term incentive and left. The Smart Accounts feature that Flare is developing takes the infrastructure one step further by addressing the user experience problem that has historically limited DeFi adoption even among users who are technically capable of participating. Currently, interacting with Flare's DeFi products requires users to hold FLR, Flare's native token, to pay gas fees, and to navigate the technical complexity of bridging assets between networks. Smart Accounts create an abstraction layer that allows XRP holders to interact with Flare's lending, yield, and DeFi products directly from their XRP wallets, without needing to own FLR, without needing to understand the bridging process, and without the technical friction that has kept most retail XRP holders on the sidelines of DeFi participation. The mechanism works by treating the Smart Account as a remote control for the user's position on Flare. When a user makes a transaction on the XRP ledger, that transaction can trigger corresponding actions in their Smart Account on Flare, executing DeFi interactions on their behalf without requiring them to directly engage with the Flare interface. For the average XRP holder who keeps their assets in a hardware wallet or a non-custodial XRP wallet and has never bridged to another chain, this represents a meaningful reduction in the barrier to accessing yield-generating and lending products that were previously unavailable to them. The significance of that accessibility improvement for ecosystem growth should not be underestimated, because the limiting factor on DeFi adoption has rarely been the quality of the underlying financial products. It has been the complexity of accessing them. The Yellow network addresses a different but complementary dimension of the infrastructure gap, where Flare is focused on bringing smart contract programmability to XRP through a dedicated Layer 1 bridge. Yellow Network is focused on solving the liquidity and trading infrastructure problem for decentralized exchanges. The fundamental limitation of most decentralized exchanges is that they sacrifice execution quality for decentralization. They are slower than centralized exchanges. They have higher effective costs because of on-chain gas fees and slippage in automated market maker pools, and they fragment liquidity across dozens of separate pools and chains rather than aggregating it into deep, efficient order books. Yellow.pro is designed to deliver the execution speed and low-cost trading that users expect from centralized exchanges like Binance or Kraken while maintaining the critical property that differentiates decentralized infrastructure. Users retain custody of their funds throughout the trading process. The network achieves this through a peer-to-peer state channel architecture that allows trades to be matched and executed off-chain at near-zero latency, while the settlement of final positions happens on-chain with cryptographic guarantees. For XRP specifically, the expectation that it will become a native trading pair on Yellow.pro means that XRP holders would have access to deep, institutional quality liquidity for trading XRP against other major assets including Bitcoin, Ethereum, USDT, and other stablecoins, without routing through centralized intermediaries that require account creation, KYC processes, and the surrender of asset custody. The chain-agnostic stablecoin payment capability that Yellow Network is building adds another layer, enabling applications to send and receive stablecoin payments that settle across different blockchains without users needing to manage the cross-chain mechanics themselves. The confidential compute infrastructure that Flare is developing addresses a dimension of DeFi adoption that is often overlooked in discussions focused on technical features and yield rates, but that is critical for institutional and regulated participation. The transparency of public blockchains is both a strength and a limitation. The strength is auditability and trustlessness. The limitation is that every transaction is visible to every participant in the network, which creates significant problems for institutional actors who have legal obligations around transaction confidentiality and for use cases involving sensitive financial data. Flare's confidential compute layer is designed to support complex transactions involving XRP ledger assets, including XRP itself and real-world assets like Rust, in a way that maintains privacy and compliance simultaneously. The target use cases include private money markets, where institutions can lend and borrow against collateral without publicly revealing their positions or counterparties, and compliant DeFi protocols, where the financial logic is executed on-chain with full cryptographic integrity, but the transaction details are visible only to authorized parties. This capability is particularly relevant for the real-world asset tokenization trend, where financial instruments like treasury bills, corporate bonds, and real estate tokens require the programmability of DeFi infrastructure combined with the confidentiality and compliance frameworks that regulated financial markets require. The combination of Flare's bridging capability, smart accounts, EVM compatibility, and confidential compute creates an infrastructure stack that is, at least architecturally, capable of hosting the kinds of institutional DeFi applications that the broader financial industry has been discussing for years but has not yet been able to deploy on existing infrastructure. The adoption data that has emerged since these systems began operating provides a more grounded basis for evaluating the thesis than projections and roadmaps. 132 million XRP bridged to Flare since September 2025. 20.9 million FXRP deposited in the first 10 days of the yield product's availability. 97% depositor retention rate. $2.5 million in additional deposits from the Zaman Partnership Vault. These are concrete, measurable indicators of user behavior, not projections about future potential. They do not prove that this infrastructure will achieve the scale required to become systemically significant. Adoption curves in technology are nonlinear, and the gap between early adopter behavior and mainstream adoption is real and often larger than early metrics suggest. But they do establish that the infrastructure is functional, that users are finding it valuable enough to allocate real capital to it, and that the retention rate suggests the value proposition is durable rather than speculative. For a nascent ecosystem that was non-existent 18 months ago, those signals are meaningful as indicators of product market fit, even if the absolute numbers are still small relative to the total size of the XRP holder base or the broader DeFi ecosystem. The larger shift that all of this infrastructure represents is worth articulating clearly because it changes the analytical frame for thinking about XRP's role in the evolving financial system. XRP is not becoming a smart contract platform. The XRP ledger is not being redesigned. The core properties that make it reliable as a settlement and payment layer, its speed, its low fees, its operational simplicity, its decade of continuous uptime, are being preserved rather than compromised. What is changing is the connectivity layer that surrounds it. Through Flare, XRP gains access to the entire universe of EVM-compatible smart contract applications without any modifications to the underlying ledger. Through Yellow Network, XRP gains access to deep cross-chain liquidity and DX infrastructure without surrendering custody. Through confidential compute and real-world asset tokenization, the XRP ecosystem gains the capability to support institutional-grade financial applications that require both programmability and privacy. The resulting architecture is modular. Different functions are handled by different layers, each optimized for what it does best, connected through bridges and abstraction layers that allow them to interact without requiring any single component to do everything. If the future of finance is modular, interoperable, and cross-chain rather than monolithic and siloed on individual networks, the question for XRP may not be whether it changes its fundamental design. It may simply be how well it connects to the infrastructure being built around it, and whether that connectivity is deep enough, reliable enough, and compliant enough to matter to the institutions that will ultimately decide which networks become part of the financial system they operate.